Hello, everybody. Welcome to Papa Lim Physics Classroom. Okay, today we'll be looking at one topic in chapter 4, which is what we know as inertia. Okay, now what is inertia? Well, I would say before I start off this lesson, I will start with an example or maybe situations. Okay, so let's say you are being chased by the elephant, or the elephant is coming down towards you. Okay, you have to run away from the elephant. If not, you have the risk of being stomped. Okay, so the elephant will stomp you, and that's it. You rest in peace already. So, what should you do other than run? Okay, should you run straight in a straight line, the shortest path from A to B, from the elephant to the shelter? Shortest path, straight line. Or should you run in a zigzag manner? So example, let's say I'm this handsome chap, okay? So when you run, this handsome chap, so when you run, should you just run in a straight line? Okay, just run to the straight line down all the way to the escape point? Or should you actually be running in a zigzag manner? What does zigzag manner means? It means this way, zigzag manner, this way, this way, this way, this way, and it reaches the end point. Okay, so it looks something like this. So you'll be running here, running here, running here, running here, running here. Okay, so be running zigzag. Although zigzag path seems to be longer, Okay, so we have a long path and a short path. The short path is a straight line from the elephant down to the shelter, or a zigzag line. Okay, a longer path, a zigzag line from the elephant to a shelter. Which path will you take so that you can actually maximize your survival rate? Okay, so to answer this question, okay, if you really already know the answer, then after that, just type down on the comment. Before you move on, just type on the comment and see what is your answer, and whether does my explanation later on resonate with you, okay, or do you really believe it? Some of us, we may not encounter elephant chasing us, but we definitely have played catching or police and thief, or these chasing games that we have when we are young. So when you want the opponent to not catch you, okay, you run away from them, but they're running away from them, hiding them in the secret place. Okay, if you don't want to do that, okay, you can actually decide whether you want to run straight or run zigzag so that they don't catch you. So what would you do actually? Okay, and to answer that question, we have everything and anything, everything to do with inertia. Okay, by understanding inertia, you have a bigger chance of actually surviving or escaping the elephant. Okay, escaping the elephant and running to the safe place before you get stomped by them or run over by them. Okay, now inertia of the object, what does it mean? Okay, inertia of the object actually refer to the reluctancy of the object to change its motion. Reluctancy means the resistance, okay, the resistance of the object. Okay, which means why we say the more reluctancy you have, the more resistance you have. So we are what we call the more unwillingness, okay, to change motion, okay, because of the mass. Okay, so what we have here is actually what we stated here is actually what we term as mass. Is actually one of the important factors that actually affect inertia. Okay, so inertia, you can unpack this word to be like what I mentioned, the reluctancy to change motion. Reluctancy means resistance, so which means you are less receptive, you are less eager to actually change motion. So what do I mean by change motion? Okay, meaning you are very, very, very resistant to actually change your current action. So example, if you are a stationary object, you're lying down on the bed. Okay, every morning I definitely have high inertia. Why? Because I need a lot of time. I need a lot of encouragement to get out of my bed. Okay, because I don't want to change my motion. I just want to lie there. I don't want to wake up. Okay, so this is what we mean by change your state of motion from stationary, okay, to action. And the reverse is also true. When you are actually on momentum, you are actually moving already. Okay, and I expect you to stop, okay, suddenly. Okay, this changes from actually motions, from actions to stop. This action from moving to stop. Okay, it requires some, I was saying, some of us, we maybe face some resistance. I don't want to stop. I just want to continue. I'm on momentum, I'm on fire now. So you want to keep doing it, you don't want to stop. Okay, and because of that reluctancy to stop, Okay, when I ask you to stop from what you are doing, okay, it tends to be a bit difficult, or it tends to take more coaxing or maybe more encouragement before you can actually change the motion. And that peculiar behavior is actually what we know as inertia. Okay, and or what we all commonly know as Newton's first law. Okay, the object will be kept as its last action, whereby the acceleration or net force is actually zero. Okay, so this inertia. Okay, now inertia is related to where? Greater mass. Okay, the bigger the mass you have, the greater is your inertia. Okay, meaning, okay, with a greater inertia means you have a greater reluctancy to change your motion. So for a big car, okay, if you at the traffic light, the moment I turn from maybe red traffic light to green traffic light, stop to go, because the car is a heavy object, you'll find that the car will take a certain amount of time before reacting. Okay, where before changing its motion from stop at the red light to moving off from the red light. This is not so obvious if you just look at the car. But like what happens if you have a car and a small bicycle or maybe a motorcycle side by side at a traffic junction. So when you have a motorbike, which is much lighter than car, okay, so the moment your red light change from red to green, stop to go, and both of them react at the same time, they press the accelerator, you'll find that the car actually jerk off or move off at a slower pace. It's not because of reaction time of the drivers or the cyclists. No, let's say they have the same reaction time. They will press the accelerator at the same time, but you will find that the motorcycle actually will move off first, will jerk off first or move off first before the car. Okay, much before. Because why? Because the motorcycle, or to be exact, the car itself has a greater mass. And because he has a greater mass, the car being having greater mass, he has a greater inertia. Meaning the car has a higher reluctancy to change the state of motion, which means just now he was not moving. Now you want him to change from stop to move. It needs some time. Okay, he has a high reluctancy, he has a high resistance. And the words that you see on the screen now are actually what we term as explanations for any questions pertaining to inertia. And usually I encourage my students, if you look at explanation questions, it's sometimes quite difficult to craft an explanation yourself, okay, and hoping that the marker will actually understand what you mean exactly 100%. So I always encourage students to take note of some explanation that we actually sieve out from past marking experience, from other markers, all these things, or what we know as the keywords. So these keywords, the effect of keywords is when you use these keywords, it tends to illustrate or it tends to portray the common understanding among all students and teachers, that the common understanding, the correct understanding of the concept that you are trying to portray, rather than you use your own word and now I might misunderstood your expressions. So the keywords that we are looking for when we look at explanation for inertia is that the students need to emphasize the mass and the inertia. What's the relationship between them and what is the factor? Example, greater mass, greater inertia. And from there, I still will not understand whether the students understand inertia. So the next sentence, the student will need to unpack what is inertia. So he has to emphasize, to link it back. The next keyword he write has to link back to the previous notes. So that previously you say inertia. So what do you mean by inertia? Okay, so that's whereby you actually unpack it to tell the marker to say that greater inertia means greater reluctancy. Okay, to do what? To change the state of motion. And after that, of course, it's better to tell the marker to say what motion are you talking about. The questions is pertaining to, or maybe from rest to move. Okay, from traffic light, stopping at traffic light to moving on at traffic light. So it will stop to move. Or maybe it could be the other way, right? It could be from moving, okay, green light. Maybe the moment I see red light, I want to stop. So what is the inertia? Okay, what is inertia between the car and the motorcycle? In this case, the inertia is the reluctancy to change motion from where? From moving to rest, to stop. Okay, so these are the keywords that I will encourage students to use so that your answer actually portray the common understanding or the common interpretation of what we mean by inertia, so that everybody, when we mark the markers, when they mark, they actually have no problem understanding your question. It's quite clear and it's not ambiguous. Okay, so this is what I mean by keywords. So now go back to the question again. So if you are chased by the elephant now, okay, one day you are chased by a big bully or a big elephant, or maybe a big cat, or maybe a tiger, okay, what should you do? Should you run in a straight line, or you actually do a zigzag manner? Okay, the answer for this, if you have not typed your answer, okay, please quickly pause the video and quickly type on the comments, okay, and check the answer with me and see what is happening here. Okay, so pause the video now to type your answer. Okay, now let's check your answer. Okay, so if you are actually running away from elephant, if you run in a straight path, okay, you find that the elephant will be able to catch you very fast, because the elephant, okay, he would, being a straight path, he will just need to run on the track, and he will just zoom all the way from point A to point B without any stopping. He will just accelerate all the way. So there's no stopping, there's no changing his speed. All he needs to do is just increase the speed straight away. And this is one of the problems. If the elephant can actually increase the speed from 0 to max without any obstacles, he has a higher chance to actually catch up with you and storm you. Okay, but of course, someone will argue, say maybe like, if it's a straight line, I can also accelerate them to my maximum in the shortest time. Yes, the answer is possible, but the problem is you have a higher chance to outrun the elephant. That is the problem. Okay, so you might not have, you have a small chance that it will actually catch up. But what happens is when you actually run in a zigzag manner. So if you run a zigzag manner, okay, so the elephant was running in the first path here. So he's trying to accelerate from the point A, maybe to point E. Okay, so what happens during the acceleration, he's on the path to accelerating. He wants to accelerate, he's accelerating halfway maybe. Okay, so he's about to hit midpoint speed already. Then after that, all of a sudden, you actually change your direction. Okay, from E, you go to F. So the moment I change my direction, the elephant will need to change direction to chase you. So when I change my direction, what I need to do is I need to stop. So for a big size elephant guy to stop, from move to stop, it needs some effort, it needs some time because of big mass. Okay, the elephant having a heavier mass, you have a greater inertia. Okay, so which means it will take some time for the elephant to actually stop moving. Okay, then after that, when he changed direction, he's about to start again. And because the same thing, because he has a big mass, he will have a big inertia to change the motion. Okay, because he has a higher reluctancy, okay, to change his motion. Now, the motion we are talking about is from stop to start. Okay, and because of that, okay, time is wasted. So time is actually wasted when the elephant is trying to stop down to stop. Okay, and time is wasted again when the elephant is trying to start off again, trying to accelerate to catch you in the different direction. So by the time the elephant catch up with you or start accelerating, you are actually maybe halfway down path F already. So at the same time now, okay, you know the elephant is behind you. He's about to catch you. Maybe he's about to catch you again. So what you do now is you change path again. In the zigzag, it change to another path called G. Okay, and this to another path, another direction in the opposite direction. Okay, so just now was left, now was right. Then after left and right, left and right, left and right. This is what we call a zigzag manner. And because every time you change your zigzag path, every time you change the path, the elephant will have to slow down. And because he has a big mass, he has a high reluctancy to change motion. And because of that, he will take some time to slow down. And after that, the inertia will come in play again. He will have a high reluctancy to change motion. Now it's stop to start. So another section whereby time is wasted again. Then after that, he will accelerate. Okay, so by then he actually has two sections whereby he has wasted a bit of time already. And by then, making these two sections good use, you are actually running away far away already. So in a zigzag manner, in this case, because you make use of inertia, you make use of the elephant mass against him, it actually allows you to actually accelerate to get away from the elephant more effectively or more safely. Okay, and this is what we mean by when you want to run away from bullies, big size guy. Maybe a car is running down the ramp and you're trying to escape it. Instead of running straight down, you actually should run a zigzag path. Okay, and which is the tendency of the person catching up with you is actually much lower. Okay, you will be able to escape. Okay, with this, okay, this is the section whereby I end off for inertia. Okay, inertia is quite a simple thing. It's simple, but yet very fundamentally quite important. It happens to us in daily life. Okay, and after the video, if you actually understand the topic, okay, you can go around looking at your daily experience. Some simple thing like running, speeding, sprinting, or swimming. See how inertia actually take place in our daily life, to how it affects our life, and even some of the choices that we make. So instead of me stopping now, I want to swim to another path. I don't want to do that because it's harder for me. Why? Why is it harder for me to change directions? Okay, look into the daily experience that you have and see whether can your physics concept actually explain it in detail, and you'll be surprised. Okay, most of our daily experience can actually be explained using physics concept. Okay, if not, okay, if you wish to share these experiences with me, you can type it down on the comments below and send it to me, and after that we can take a look and we can actually resonate with each other. Maybe what happens to you actually happens to me also. Okay, if not, okay, see you in the next lesson. Thank you and have a great day ahead. Bye-bye.